Good morning. I hope you had a restful weekend. Just a reminder that your culminating activity is due pretty shortly. Okay, that is on the 8th, so that's next Friday, not this Friday, but next Friday. So make sure you're working on that. Come to me with any questions you might have. Otherwise, let's jump right into our lesson for today. Good morning. Happy Monday. Let's go ahead and jump right in. Okay, you do have an exit ticket due by midnight tonight. Don't forget to take care of that. Now, today, I really just want to practice. Okay, so specifically practicing evaluating these limits using our ideas of vertical and horizontal asymptotes. So work through the problem, pause the video while you do so, come back, watch me work through it, check your answer, and then we'll move on to a new problem. Okay, so there's 4 practice problems today. The first asks us to evaluate the limit as x approaches infinity of 2x cubed over 3x cubed minus 7x. Now, anytime we have a limit as x approaches positive or negative infinity, anytime we see this or negative infinity in there, we should automatically be thinking about our horizontal and slant asymptote rules. Okay, so thinking about this function, where would it have a horizontal or slant asymptote? That depends on whether this function is top heavy, bottom heavy, or equal. Now, in this case, the degrees of the numerator and the denominator are equal. And since they're equal, it would have a horizontal asymptote at wherever its leading coefficients are. We divide those leading coefficients, which means that this limit is the same thing, 2/3. Okay, equal. So the limit, we just divide the leading coefficients. That's it. Same rules as our horizontal asymptotes. Here, they're asking us to find any vertical asymptotes and determine the behavior of the function to the left and to the right of each. We have the function f of x equals 4 over x squared minus 100. Well, we're going to have vertical asymptotes wherever the denominator equals 0. And so we solve this and we get x equals positive 10 and negative 10. Now, in order to determine the behavior to each side of the asymptotes, in other words, the behavior as x approaches negative 10 from the left and from the right, and the behavior as x approaches positive 10 from the left and from the right, we're going to graph this. Okay, and so I pulled this up on Desmos and I got a function that looks basically like this. And this was negative 10, this was positive 10. So as x approaches negative 10 from the left, so as we're coming at that x value from the left, is the function going up or going down? Clearly, the function's going up, which means that limit is approaching positive infinity. To the right of negative 10, as we're approaching that x value, the function's going down, which means we're approaching negative infinity. And we do the same thing to the left of positive 10 and to the right of positive 10. And that's how we get the behavior to each side of the asymptotes. Okay. So when we have 2 asymptotes, we actually have 4 things we need to write here, right? There's 2 sides to each asymptote. Okay. But otherwise, it's the same rule that we had before. Find the vertical asymptotes, set the denominator equal to 0. Evaluate the limit as x approaches negative infinity of this function. Again, anytime we're taking a limit as x approaches positive or negative infinity, we're thinking about our horizontal and slant asymptote rules. This particular function is bottom heavy, which means that as x approaches a really big positive number or a really big negative number, since the degree of the denominator is larger, this entire fraction is getting smaller and smaller and smaller. As we get infinitely large in the denominator, this whole fraction approaches 0. Okay. In the same way that a bottom heavy function had a horizontal asymptote at y equals 0. Same rules, just slightly different notation. And our last problem today, the limit as x approaches positive infinity of x squared over x minus 1. This is a top-heavy function, so ordinarily we would have a slant asymptote. But if we have a slant asymptote, can we say that this function is approaching any particular y value? Not really. It's approaching another function itself. So in this case, there actually isn't a single limit value that we would find. So we say that this limit, dne, does not exist. Yes, the limit does not exist because it's top-heavy. That's basically it. Okay, so hopefully this practice wasn't too bad for you. Your exit ticket will ask you to go through a couple of these problems as well. Keep practicing, work through that 9.1 independent practice, finish that exit ticket by midnight tonight. Tomorrow we'll finish up the very last page of our notes for section 9.1, and then we'll practice Thursday, take that formal exit ticket that's going in the grade book on Friday, and that's it for this last unit. Like I said, it was only this one section. So we'll finish that by the end of this week. We'll spend next week reviewing, and your culminating activity, that final, is due next Friday. Then after that, we'll basically be done. Okay? So keep at it. Come to me with any questions or concerns, and I'll see you later. There you have it. I hope you had a great lesson. Just let me know if you have any questions. I'd like to think of myself as a vastly superior teacher to Boothman over there, but, you know, who's to say? So make sure you complete that exit ticket. Please stay engaged. We're almost there. Push yourself just a little more, and we'll get through the end of this together. Thanks, and have a good one.